Okay, let's get right into it. AMC Math 2017. Question one, which of the following values is largest? Okay, this is just 10 here. 2 plus 0 plus 1. This 2 times 0 here zeroes out. We get 8. This 0 times 1 zeroes out. We get 9. This is 2 plus 7, which is 9. And this always zeroes out. So A is answer number 1. Question number 2. Alicia, Colby, and Brenda, or Alicia, Brenda, and Colby, A, B, and C. They use this a lot to make it easy for you. A, B, and C were candidates in a recent election for student president. Pie chart shows how many votes were distributed among the 3 candidates. If Brenda received 36 votes, how many votes were cast altogether? So 30%. Let's see, we have X total votes. X total votes. Just one equation. 3/10 of X equals 36. We multiply both sides by 10/3, right? Reciprocal of X, the reciprocal of the coefficient of X. We multiply 36 by 10/3. This is why you've got to be really fast at simplifying, factoring, and everything else, is all math is. 36 divided by 3 equals 12 times 10. 120. There are 120 votes altogether. Okay, same thing here. Let me get my pen over onto the board. Go back with our green pen. Okay. What is the value of this expression? It's a triple radical. Whenever you have these expressions, you start in the middle. Square root, or start on the inside. Square root of 4 equals 2. 2 times 8 equals 16. The square root of 16 equals 4. So now you have the square root of 16 times 4, which is the square root of 64, which of course is 8. A 1-second question. Now here, number 4, when this decimal is multiplied by this big number, the product is closest to which of the following? Okay, so this right here looks like 8 million. I'm going to write 8 million. I'm going to write 8 times 10 to the 6 zeros, right? 3 here and 3 there. And we're going to multiply this by, well, let's just get rid of this 1 and this 5. This isn't 3/10, it's not 300, it's not 3,000, it's 3 over 10,000. So we multiply it by 3 and we divide by 10,000, right? 10,000 has 4 zeros. So that is 10 to the 4th. All right. So 10 to the 6th divided by 10 to the 4th naturally equals 100, right? 10 squared. So this is going to be, let me just write that out. 10 squared times 3 times 8, which is 24. It should be 2,400. Let me just double check this. So this is 8 million with 8 with 3 zeros. This is 3 over 10, 100, 1,000. 3 over 10,000, that's 4 zeros. All right, so it should be 2,400. Okay, problem 5. What is the value of this expression? This is the product of the first 8 numbers over the sum of the first 8 numbers. Now, the sum of the first 8 numbers, I'm going to write it over here. I'm going to start on the bottom. The sum of the first 8 numbers is 8 times 7. I'm sorry, 8 times 9 over 2. It's 36. Okay, it's 72 over 2. It's 36. Now, I'll get to this in a second. So the denominator is, I'll come back to it in a second. The denominator is 36. And actually, what I'm going to do is I'm not going to, let me hit the back arrow a couple times. I'm just going to write 4 times 9. I'll write 4 times 3 times 3. And let's look at our numerator. We ignore the 1, 3, 4, 2 times 3 times 4 times 5 times 6 times 7 times 8. And let's just reduce, right? Let's use a different color. This 3 cancels with this 3. And 4 times 3 is 12, right? And we'll cancel out a 12 here. 12 on top, 12 on the bottom. 4 times 5 is 20 times 56. Well, let's just double it. We'll make it 2 times 56 is what? 112 with a 0 on the end. 1120. Okay? We should be right here. Okay, if the degree measures of a triangle are in the ratio of 3 to 4, 3 to 3 to 4, what is the degree measure of the largest angle? So we should know this inside and out, that the angles of a triangle add up to 180. And our three angles are not 3, 3, and 4. They're 3x, 3x, and 4x. So 180 equals the sum of these three angles. So we have 10x. Let's see, 7. We have 10x equals 180. X equals 18. That means the largest angle is going to be 4x right here. 4 times 18, we should know it's 40 plus 32. It's 72. 4 times 18 comes up all the time. A lot of people don't know their multiplication tables. They don't know 3 times 16. They don't know 4 times 16. They don't know 4 times 18. They come up over and over and over again. It's pretty handy to know them. All right, let z be a 6-digit positive integer such as this. The first 3 digits are the same as the last 3 digits. Which of the following must be a factor of z? Now, I've seen this question a million times. Let's just try these numbers here. Let's just, we really shouldn't do it this way. But let's just, for kicks, let's just divide 11 into it. 247, 247, divide by 11. How many 11s in 24? 2. 22, 27, let's see, it's going to be 22, 27 minus 22. How many 11s in 52? That's going to be 4, 44, 84. How many 11s in 84? 7, 7 times 11, 77. What do you know? 11 divides into it, okay? So it could be 11. Now, I don't want to divide 19, 101, 111, and what's that? 1, 1, 1, 1, 1, 1, 1, 1 into it. So let's look at this a different way. Okay, so we know that 11 divides into it. Okay, let's look at the general case. Now, the general case is A, B, C. Those are the first 3 digits, and those are the last 3 digits. Okay. Let's come way over here. Okay, now if we were to write this out, if we were to expand this, this would be C plus 10B plus 100A plus 1000C. Right, because this C represents thousands, and it's going to be plus 10,000. One more. It's going to be plus 10,000 B plus 100,000 A. 1 with 5 zeros A. All right. So this is what this looks like in expanded form. Let's look at it here and see if we can figure out what is going on here. Well, how many A's do we have? We have 100,000 A's and 100 A's. So we have 100 and 100,100 A's. We have how many B's? We have 10,000 B's plus 10. We have 10,000 and 10 B's, and then we have 1,001 C's. What is going on here? This should be a 0. We have 1,001 C's. All right, so it looks like we could factor out 1,001 here, doesn't it? So 1,001 times 100A plus 10B plus C. This is not right. This should be 1,001. Let me rewrite that. So it looks like, where's my pen? There's an art to using this pen here. So it's divisible by 1001. Okay, so no matter what our number is in this form, it's always going to be divisible by 1001. Okay, well, does that help us? Well, it does, because we can now factor 1001. And let's see. 11, we know 11 goes into the whole thing, but let's just double check that 11 goes into 1001. Let's do it up here. 1001 divided by 11. There are 9 11s in 100. We have, it's 91 times 11. So this basically is 11 times 91 times 100A plus 10B plus C. 91, we should know that factors into 7 times 13. And I'll write this in this digit form like we had up here. So every number that's in this form, 247, 247, or ABC, ABC, it could be 682, 682, it could be 682, 682, it could be, let's do another one, it could be 714, 714. It's always going to be, where's my thing? It's not letting me go down. Why not? Why not? Why is it sticking me here? All right, it's always going to be in this form of, move my mouse, of 11 times 7 times 13. So it's always divisible by 11. It's always divisible by 7 and 13. Now, these other numbers here are not necessarily divisible by 7 and 13. Definitely not 101, which is, I believe, prime. And definitely not 19. So our answer is going to be 11. All right, let me just stop right here for a second. All right, so this question here, I mean, I spent a lot of time doing it out manually, but if I was doing it for real, I would just be able to look at this number right away and tell that it's divisible by 11, and then eliminate some of these other ones by process elimination real quickly. And I don't want to go into it, but you should definitely know how to tell if a number is divisible by 11 just by looking at it. That is an important skill you need to have, and you can find that online easily. I'm not going to go into that right now. So let's look at question number 8. Let me make sure my pen is back. It's acting a little wacky there. I had to pause. Okay. So let's go. My pen looks like it's back. All right, good. Wasn't letting me go low. All right, Malcolm wants to visit Isabella today after school and knows the street where she lives but doesn't know her house number. She tells him my house has 2 digits. All right, I'm going to slow down right away. When it's 2 digits, we know it's between 10 and 99. Okay. And 3 of the following 4 statements about it are true. So 3 are true, 1 is false. So 1 is, what we're looking for is contradictions, right? So, for example, if it's prime, okay, it's prime, it's even, it's divisible by 7, and our street number also has one of the digits being 9. Now, a number can't be prime and divisible by 7 unless it's 7, right? So, and 7 is 2 digits. So it can't be both of those. So it's either going to be prime or divisible by 7. All right, so let's just assume that it is, well, we can do it either way, but let's just assume it's prime. Okay, so if we assume it's prime, then it can't be even, right, unless it's 2, which can't be true. So if it's prime, it can't be divisible by 7. It has to be even, and one of its digits is 9. I mean, we can pretty much eliminate this prime criterion right away because it's very hard to be divisible by 7 and prime, right? We're going to get a contradiction real fast. So let's just say that these are the 3 criteria. It's even, it's divisible by 7, and one of its digits is 9. So it's even, it's divisible by 7. So, 7, 14, 28, 35, I'm sorry, missed 21, 21, 35, 42, and so on and so forth. There's only about 14 numbers that are below 100 that are multiples of 7. We don't see any 9s here yet. One of its digits is 9. And we also know that it's even. Okay. So it's even and it's divisible by 7. All right, so even and divisible by 7 means it's going to be 14, 28. It's going to be a multiple of 14. 42, 56, 70. We're adding 14, 84, and 98. Only one of these has a digit of 9, so that's 98. So what is its units digit? 8. So let's just check again. It is even. 98 is even. It is divisible by 7. It's 7 times, what? 7 goes into 9, 1. And it's 7 times 14. And one of its digits is 9. So we are done there. All right, all of Marcy's marbles are blue, green, blue, red, yellow, or green. So let's do, we got blue. We got blue. I'm going to write them all in green. I don't care. Blue, red, yellow, and green. 1/3 of her marbles are blue, 1/4 are red, and 6 of them are green. So we know 6 are green. 1/4 are red. Well, let's just say we want to say they're X total marbles. X total marbles. So 1/4 of her total, 1/3 of her total, the blue ones are going to be X over 3. 1/4 are red, X over 4 are red, and we don't know anything about yellow. What is the smallest number of marbles Marcy could have? Actually, we do know how many yellow marbles she has, right? Because these 4 categories must add up to X. So we have 1/3 X, we have 1/4 X, which is, let's see, 4/12 and 3/12. That's 7/12 X. And 6. So this actually has to be 5/12 X. I'm just going to write this in. I don't even know if we're going to need it. 5/12 X minus 6, right? Because all 4 of these need to add up to X. That's what we've defined as being the total number of marbles. All right. So what is the smallest number of yellow marbles Marcy could have? So X is actually an integer, right? She can't have a mixed number or a fractional amount of marbles. And we know that yellow has to be 5/12 X minus 6. So right away, we know that X has to be a multiple of 12. Let me write this out here. 5/12 X minus 6. Right away, we know X has to be a multiple of 12. Otherwise, we would never, this factor would not cancel out with 12 in the denominator, and we would not get a whole number of yellow marbles. You can't have a fractional amount of marbles unless you're really crazy. So X has to be a multiple of 12. So X could be 12, it could be 24, it could be 36. And since we want to know the smallest number of marbles, well, if we plug in 12, we get 5/12 times 12 minus 6. Right? The 12s cancel, and she has -1 marbles, which means she's really, really loco. So that's not possible. But if we plug in 24, 5/12 of 24, and subtract 6, what do we get? 12 goes into 12 once, 24 twice. We get 10 minus 6, we get 4. Looks like the smallest amount of marbles she can have is 4. And let's just check. Let's just say she has 4 yellow marbles. And what did we say? We said she had 24 total. 1/3 would be 8. 1/4 would be 6. And there are 6 green ones. So if we add these up, we get 14 and 10. We get 24. Everything checks out. Okay, let's pull my eraser over. Let's go to the next one. Probability question. Box contains 5 cards. 3 cards are selected randomly without replacement from the box. What is the probability that 4 is the largest value selected? Okay, so we're going to choose basically 3 cards. I'm stuck with red. Out of the 5, and one of them has to be a 4. Okay, so let's just think. Whenever you do probability, you always want to draw a fraction. You want to think, how many ways can I choose 3 out of 5 cards? You can write it like this. 5, choose 3. You can also write it as 5, choose 3 with this, this like matrix form. You should know this. I don't want to go into it too quickly here, but it's 5 factorial over 3 factorial, 2 factorial, right? So if you don't know what I'm talking about here, you want to look up combinations in probability. You'll find it on Khan Academy. You'll find it in lots of other places, right? So it's a pretty standard number to know. My students need to know this number by heart, all right? So 5 choose 3. The number of ways I can choose 3 out of 5 is 10. It's the same as the number of ways that you could choose 2 out of 5, right? And it's related, of course, those of you that know, to the binomial tree. Where is my pen? My thick pen. It's related to the binomial tree. Should I write the binomial tree out? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is kind of small. Maybe I'll 1, 5, 10, 10, 5, 1. And that's what we're looking at right now. This is this number here. Maybe I'll enlarge it. Is 5 choose 2. Oh, sorry, it's 5 choose 1. Let me hit that back. I'm going crazy here. Back arrow. It's 5 choose 1. This is 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3. So we have 10 for our denominator. So there are 10 ways that we can choose 3 cards. Now, how many of those ways have 4 as the biggest? Okay. So let's change our color a little bit. So we're going to have a 4, and we're going to have 2 others. So what it boils down to is how many ways can I choose 2 out of the numbers 1, 2, and 3? Because remember, we can't have a 5 in there. 4 has to be the largest. Well, there are 3 ways that we can choose 2 of these numbers, right? You could do 1, 2, 4. You could do 1, 3, 4, and you could do 2, 3, 4. Let's excuse my writing. So there are really only 3 combinations that you could choose out of the 10. So the answer would be 3/10, unless I made a mistake. All right, let me delete this and go back to the next question. My eraser. Let's see, and then we pull it back. Okay. A square-shaped floor is covered with congruent square tiles. The total number of tiles that lies on the diagonal is 37. How many tiles cover the floor? So this is all about patterns, right? They don't expect you to draw this out, but they expect you to uncover the pattern. So let's go back to my green. Let's just look at a 3 by 3. Let's just draw a 3 by 3 square. Oh, that's gonna be terrible. 3 by 3 square, and let's look at the diagonal, like a tic-tac-toe board. So along our diagonal, we have 1, 2. Oh, it's not letting me draw on it. 3, 4, 5. So when we have, give me a break, my pen. When we have 3 sides, we have 5 tiles on the diagonals. Now what about when we have 4 sides? So we have to draw a 4 by 4 square. Oh, my pen is acting up. My pen is acting up. I have to go to the mouse for a second. Okay, so if we go to a 4 by 4, how many sometimes pencil and paper is easier. So how many are on the diagonal? 1, 2, 3, 4 tiles in this diagonal, then 4 on the other. Okay, so if we go back to blue here, it was this blue. So we have 4 and 4, we have 8. Okay, so one thing you might have noticed is that if there's an even number of tiles, there's no overlap, right? So let's see, so 5, 6. But once we get into a 5 by 5, I'm going to try my pen again. Once we get into a 5 by 5, you have to know how to draw these 5 by 5s. I draw 1 on the side, then I just cut the larger piece in half twice. I'd say you get 5. Same thing. I look like I lop off like a fifth over here, and then I just cut these into quarters here. If you have a 5 by 5, 1, 2, 3, 4, 5, 6, 7. This is double counted. So we don't have 10, right? We have 5 and 4. We have 9. Okay, that's all right. We can write in red. But when we have 6 again, we're going to get 12. Okay, so when n is even, if you have a 2 by 2, 4 by 4, 8 by 8, 20 by 20, you're just going to double it to find out the number of tiles on the diagonal, right? So the question is when is this 37? Well, it would be 36 when we have 18 sides, right? It will be doubled. 37, I think, when we have 19 sides. That makes sense to me. One less than doubling it, right? So because there'll be 19 on one diagonal and 19 on the other, but this won't be double counted. So it should be, we should have a 19 by 19 square. All right, now it says how many tiles cover the entire floor. They're asking us what 19 times 19 is, and that is 361. I have memorized that. There are many ways to do it. You could also do a square double square with this, 400 minus 40 plus 1. There's lots of ways, but you should know the squares. The kids should know the squares up to 25, right? You don't stop at 12 times 12. So we have 361 tiles on the floor. Okay. Okay, so question number 12, the smallest positive integer greater than 1. This is always a very verbose way they say these things. So we're looking for a number, the smallest number. Where's my green? Greater than 1 that leaves a remainder of 1. When divided by 4, 5, and 6, lies between which of the following pairs of numbers? Now again, if you haven't seen these questions before, the verbosity of the posing of it can intimidate you. So that's why I'm here to help you translate. So we're looking for a number. We're always looking for a number in math, right? That when you divide it by 4, 5, and 6, it leaves a remainder of 1. Okay, so the easiest way to find this number is to multiply 4 times 5 times 6, and then add 1. Okay, 4 times 5. Well, let's just look at this before we check it. If we divide this number by 4, we're going to get 20. We're going to get 20. 30 plus 1. So it's 1 more than a multiple of 30. If we divide it by 5, we're going to get 24 plus 1. Let me just show you this. So 4 times 5 is 20, times 6 is 121. This right here equals 121. If you divide it by 4, let me write it out. 121, I don't want to make this too complicated, equals 30 plus a remainder of 1. If you divide 121 by 5, you get what? 5 goes into that 24 plus a remainder of 1 left over. If you divide 121, not 126, by 6, you get 20 with a remainder of 1. So 121 definitely works, and they're definitely trying to get you to do to guess E or to mark down E. But 121 is not the right answer because there is a lower number. So what we came up with was 4 times 5 times 6 plus 1, or 121. Really, the first thing you want to do when you get these questions is you almost want to cut this in half. This isn't the best explanation, but it's going to be smaller than that. So this number is 120, and if you just looked at 60, right? 60 plus 1. You would see that if you divide it by 4, you get a remainder of 5. If you divide it by 5, you get a remainder of 1. If you divide it by 5, you get a remainder of 1. And if you divide it by 6, you get a remainder of 1. All right, so 61 works. So the answer is going to be 61. Now let me just show you why. Because if we factor this, this is 2 squared times 5 times 2 times 3. plus 1. Well, really, being divisible by 6, we already have a factor of 2 in here. So we really just need another factor. We're just adding a factor of 3. So it's really 2 squared to be divisible by 4, a factor of 3, and 5. So 4 times 3 times 5 is 60. Okay. Maybe not the best explanation, but you'll see these questions over and over and over again, and they become pretty easy. All right, problem 13. Peter, Emma, and Kyler played chess with each other. Peter won 4 games and lost 2. Okay, so we have Peter. How are we going to do this? Peter, Emma, and Kyler, a name I've never seen before. They played a bunch of chess games, so they've got a win column and a loss column. Wins and losses. Okay, go back to green. Well, we can say blue. All right. So let's fill in what we know. Peter won 4 games and lost 2. Emma won 3 games and lost 3. And Kyler lost 3 games. Okay, well, it looks like there were 8 losses. So it looks like there needs to be 8 wins. So Kyler must have won 1 game. Okay, that's an easy question. That's that answer. That answer there was 61. And let's look at Chloe and Zoe. Chloe and Zoe are both students in Miss Demeanor's math class. That's a joke, by the way. Miss Demeanor. Demeanor. I'm do cursive. Last night they each solved half the problems of their homework alone and then solved the other half together. Chloe had correct answers to 80% of the problems she solved alone, but 88% of her answers were correct. Okay. Zoe had correct answer to 90% of she solved alone. What was her overall percentage of correct answers? All right, this looks like a question of weighted averages. Okay, let me just think about this for a sec. So she had correct answers to 80% of the ones that she solved alone. Okay, let's write this out. Chloe and Zoe. Okay, so she had 80% of the ones that she did alone, but overall she had 88%. Okay, so the other one had 90% of correct that she did alone. Okay, alone and together, cheating. They did better together. 88%. So we're missing one other thing here. Okay, so actually a few other things. Together, and this is total. Okay, well, we know this is half. Okay, so we can make use of Chloe's information. So, I mean, you can pretty much see that, you know, half the questions she did alone and the other half she did together, and her average went up 8 points. So together she probably did 16 points better than this. In other words, she probably did 96%. Got 96% of the questions she did together alone. Now let me just, I don't know if I need to do this, explain this further. What a weighted average is. She did half the questions by herself and half together. So this is a pretty easy average that her total is going to be in between, right? She got, okay. So Zoe, same thing. So she did 90% alone, and she should have 96% of the ones she did with Chloe right as well, because they handed in the same work for the second half of questions. So she should be 93. Okay. It's not that hard, but it's a lot easier if you write it out. Okay, problem number 15 should be on that. Let's see, problem number 15. Arrangement of the letters and numerals below. How many different paths can one spell AMC 8? Beginning with the A in the middle of path allows only moves one letter adjacent. All right, above, below, right, left, right, or diagonal. but not diagonal. One such example is this. So how many ways can we spell AMC 8? So let's do some green. So we got 1. We could also go 2, 3, 4, 5, 6, 7, 8, 9. All right. 10, 11, 12, 13. Probably missed some here. 14, 15, and 16. I don't know, maybe 17. This is not going to be how we get our answer. 17, 18, 19, 20. All right. I feel like we missed some here. All right. Might have missed this one. 21. Okay. So the question is how can we figure out, now that I made a mess of this, how can we figure out for sure how many paths there are? So let me just refresh this page. Okay. So we're back. Let's look at it again, and let's try to add these paths up. So for every A, we can go to 4 M's, right? So we can go, there are 4 M's. And let's see if we can find some symmetry here. For every M, we have, looks like 1, 2, 3 C's. This M has 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 3 C's, right? So then we have 3 C's. Try to make a small C, S there. 3 C's. And from every C, we have 2 8s, right? From this C, we have 2 8s. From this C, we have 2 8s. There's a lot of symmetry going on in this question. All right. So from every C, we have 2 8s. Okay. So it's 4 times 3 times 2. 12. It should be 24 total ways. And what did I count? I counted in the low 20s, right? I probably missed a couple. So that's probably right. Okay. So let's read this one here. In the figure below, choose D on BC so that triangle ACD and triangle ABD have equal areas. Hopefully you already tried to go through this question, so you have some frame of reference. Let me see if I can get my pen to work again. It's acting a little wacky. All right. So we're going to choose a point here such that these two triangles, you can use a line tool here if I want to make straighter lines. There we go. These lines, these triangles, this one here, this bottom one, and this top one have equal areas. So let's just, let's call this side length here D. I'm sorry, have equal perimeters. So let's just calculate the perimeters of both sides. Actually, we can't. We need to call this X, and we need to call this 5 minus X. Make that a 5 minus X. Okay, so now we have our two triangles. The lower triangle has a perimeter of 4 plus X plus D. And we know that has to be equal to 3 plus 5 minus X. 5 minus X plus D. Okay, we have a D plus D on both sides, so they will cancel out, right? And let's see, we have 3 and 4 and 5. Looks like we're going to have 8 over here and 4 there. Bring them over here. 2x equals 4. X equals 2. So it looks like this is going to be 2. And this is going to be 3. So let's look at these two perimeters now. This perimeter here is 6 plus D. And this perimeter here is 3 plus 3 plus. It's also 6 plus D. Okay, so we've got our initial condition satisfied. Let's try to create some space here. We can even erase that. All right. So, back my pen. All right. So now we want to find out what the area of this lower triangle is here. Now, what is area? Area equals 1/2 base times height. Okay, so we could consider 4 to be our base, and then we would need to figure out what our height is here. Or we could consider 2 to be our base, and we can figure out what our height is here. This height is outside of the triangle. Remember, that can happen in an obtuse triangle. There are a couple other ways we can figure out the area as well. So let's look at what we know. Whenever you get stuck in math, you always just have to go backwards. What do we know? We know we have a 3, 4, 5 triangle. We know the area of the whole thing is, applying this formula, is 1/2 times 3 times 4. The area of the whole thing is 6. Okay, that's the area of the whole triangle. Okay, and if we know the area of the whole triangle, normally with these right triangles, this is a right triangle, right? We just multiply the two legs and by 1/2, and we get our area. But you could also use this altitude here and this 5. In other words, if we looked at this triangle upside down, right, and we had a 5 here, a 3 here, and a 4 there, and we drew this dotted line, we should still be able to get an area of 6 if we looked at it this way. So in other words, 6 should equal 1/2 base 5 times the height. Okay, so we have the height now equal to, let's see, this is 5/2. You multiply both sides by 2/5. Let's see, am I making a mistake here? No. And we get h equals 12/5. Okay, so this height here is 12/5. 2.4, right? 2 and 2/5. 12/5. All right, so if we know this height, and we know the base is 2, well, then the area, remember our formula here, 1/2 base. Remember, we're trying to find the area of this triangle here. Our base is 2, right here, and our height is 12/5. Okay, so 2 and 1/2 cancel out, and so we get the area of this little triangle is 12/5. Okay. 3, 4, 5 triangles, they work them to death. Okay, problem 17. Starting with some gold coins and some empty treasure chests. So gold coins and treasure chests. I tried to put 9 gold coins in each treasure chest, but that left 2 treasure chests empty. So instead I put 6 gold coins in each treasure chest, and then I had 3 gold coins left over. So how many gold coins did I have? All right, so first thing you want to understand is that there's 2 unknowns. Okay, some gold coins, let's call this one X. We have X gold coins, and we have Y treasure chests. Okay, so we have X coins and Y chests. Okay, let's see. C's and C's. We'll make them X and Y's. I tried to put 9 gold coins in each treasure chest, but I had 2 treasure chests empty. So if we had, 5 treasure chests and you put 9 in, well, you'd only be able to put 9 times 3. Okay, so hold on. So if we subtract 2 chests and we put 9 in each of them, we get actually the number of gold coins. All right, let's just double check that. So we took all the coins and we just started putting them in all the chests except for 2. And we had 9 in all of them except for 2. So let me just think. Does this make sense? We take away 2 chests and put 9 in each one of them. So 9 times the number of filled chests equals the total coins. Okay, that's right. Anytime you get, and why am I trying this? Because anytime you get a question that has 2 unknowns, you can pretty much assume that they want you to find 2 equations. Create 2 equations that represent their relationships, because you need 2 equations to solve for 2 variables, generally speaking. All right. So let's look at the second bit of information. So instead, I put 6 coins in each treasure chest. So 6 coins in each treasure chest, but then I had 3 left over. So 6 coins in each treasure chest. Now that doesn't give me the total coins. it gives me the total coins, 3 less than the total coins, x minus 3, because we had 3 left over. Okay, so now we have our 2 equations with 2 variables. Let's just, I don't know, let's make this first one 9y minus x equals, we'll bring the negative 18 over, equals 18. And this other one here, let's make it 6y minus x equals negative 3. Okay, so this is our system. We want to get rid of these y's. So let's just subtract the bottom equation from the top equation. 9y minus 6y. Oh boy. Every time we get to the edge of this thing, it gets a little messy. We get 3y, negative x minus x is 0. 18 minus negative 3 is 21. We're getting y equals 7. So let's put a 7 here. We have 7 chests. And if y equals 7, we know let's just plug into either equation. 6 times 7 equals x minus 3. So 42 equals x minus 3. X has to be 45. So there are 45 total coins. Okay? Let's clean this up. Let's make this bigger. Let's crop that out. And actually we can do this. Control A, resize and increase it 50%. All right. No, 150. Oh, that didn't work. Didn't work. All right. Maybe you can't increase it. All right. We have a non-convex quadrilateral. That just means a quadrilateral that folds in on itself. Okay, so this angle here folds in, right? This would be less than 180, less than 180, less than 180, and this angle here would be more than 180. That's all non-convex means. It folds in on itself. BCD is a right angle. Let's indicate that with our little square. AB is 12. BC is 4. CD is 3. Okay, I'm already seeing 3, 4 in a right triangle. I'm already knowing that this is going to be 5. And you should know as well. Okay, so this is going to be 5. And what else do we know? BCD is a right angle. And there's one more thing. AD is 13. All right. So the whole thing, 5, 12, 13, you should recognize that as the second most common right triangle. What is the area of the quadrilateral? Okay, so the quadrilateral is a triangle, a big 5, 12, 13, minus a little 3 by 4, 3, 4, 5 triangle. All right, so it's going to be 1/2 5 times 12 minus 1/2 3 times 4. So 1/2 of 60 is 30 minus half of 12, which is 6, so it should be 24. Okay, it's a pretty easy question. I love geometry. It's always right triangles. It's always 3, 4, 5. It's always 5, 12, 13. It's actually pretty easy geometry. I think it's a lot easier than stuff like probability, where you can't see everything and you can miscount very easily. Okay, for problem 19, for any positive integer m, the notation m factorial, okay, we should know what m factorial means. It means the product of numbers 1 through m. What is the largest integer? Now, incidentally, if your child is in 5th, 6th, 7th grade, they probably don't know what a factorial is. And this is why you really can't compete at the high levels on these exams if you just do school math, if you're not doing something above and beyond, or a lot above and beyond. All right. So you have to know what a factorial is, and you have to be very fluent in using them. All right. So what is the largest integer n for which 5 of n is a factor of this sum? All right. It sounds all crazy, math, whatever. They just want to know how many factors of 5 are in this sum. So anytime they want you to know, look, all algebra is factoring. You're just basically going to reflexively factor almost everything you see. So what's the biggest common factor in all 3 of these terms? Well, it's going to be 98. Give me a thick pen. It's going to be 98 factorial. And 98 factorial times 1 gives me 98 factorial, times 99 gives me 99 factorial, and then We're missing 2 terms here, or 2 factors. What is that? 99 times 100. Okay, right there. So let's just continue to simplify. 98 factorial. 1 plus 99 is 100. This is 9900. 9900 plus 100 is also known as 10,000. Okay, so now we have this in this nice little factored form here. And we just want to know how many factors of 5 there are in it. Okay. Well, 10,000 is easy enough, right? It's 10 to the 4th, or 2 to the 4th times 5 to the 4th. So we got 4 factors of 5 in here. Question is, how many 5s are in the product of the first 98 numbers? Well, if we just look at, like, we know we have a 5, we have a 10, we have a 15, we have a 20, we have a 25. How many multiples of 5 are there up through 98? Well, there are 19, right? 5 times 19 is 95. So we have 19 factors of 5, okay? We actually have a couple more, right? Because 25 has an extra one. This is 5 squared. 50 also has 2 times 5 squared, and 75 is 3 times 5 squared. So there are actually 3 more factors of 5. So let's just do plus 3, 3 more. All right, so now we have 19 plus 3 is 22, plus these are 26 total factors of 5. So it's really going to be divisible by 5 to the 26th power. Okay? Not a hard question. Remember, factor, 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 reflexively. Okay. Number 20, integer between 1,000 and 9999. So basically a 4-digit number is chosen at random. What is the probability that is odd and that its digits are all distinct? So it's going to be odd and the digits have to be distinct. Okay, so always draw these 4 slots here, and let's look at the possibilities for each slot. So it has to be odd. So let's change colors. So there really only are 5 possibilities for the 4th digit. Okay, well, actually, before we do that, how many total digits are there? So, how many total possibilities are there? So there are 4 slots. The first digit can be anything between a 9 and, between a 1 and a 9. It can't be 0. So there are 9 possibilities for the first digit. The second digit can be 0, 1, 2, 3, 4, 6, 7, 8, or 9. So there are 10 possibilities there, 10 possibilities there, 10 possibilities there. So whenever we go into probability, remember, it's just a fraction. It is the number of ways we can get the specific desired outcome divided by the number of total outcomes. The number of total outcomes is 9 times 10 times 10 times 10. There are 9,000 possible 4-digit numbers. So let's come back up here and look at the ones that meet our criteria. It has to be odd. So the last digit has to be 1, 3, 5, 7, or 9. So there are only 5 possibilities for the last digit. Now, let's come up to the first digit. Right? The first digit, remember, it can't be 0. So we're already down to 9 digits, and it can't be this one. So there are actually 8 possible digits for the second digit. Or at least, the leading digit. So now let's look at the hundredths place. Right? So the hundredths place, it can't be one of these 5. It can't be whatever we chose for the first digit. So we used to have 10. Now we have 8 possibilities. Okay? And the same thing for the tens place. There used to be 10 possibilities for it. And we can't be any of these other 3 digits, so we're down to 7. So the number of numbers that have 4 digits that end in an odd number and all the digits are distinct is going to be 8 times 8 times 7 times 5. So this is our answer here. So now we have to reduce this. So let's see, how do we reduce this? Well, let's factor it. Let's make it 2 cubed times 2 cubed times 5 times 7. And let's look at our denominator. It looks like we have 3 squared times 2 cubed times 5 cubed. Okay, let's cross some stuff out here. This 2 cubed cancels out with this 2 cubed. 1 5 here makes that 5 squared. And And I think that's it. So it looks like our numerator is 8 times 7. Looks like 56. So it's probably going to be this answer here. Our denominator is going to be 3 squared times 5 squared, which is also 15 squared, or 225. Okay? So it's definitely going to be B. And again, that's why I like geometry over probability. You can miscount and have no idea that you miscount. If you make a mistake in geometry, the answer is probably not going to seem right. There might be some hint that you're wrong. All right, 21. A, B, and C are non-zero real numbers. So that means none of them are zero. They're all positive or negative. What are the possible values for this expression here? Now let's just think. Well, where do we want to start? Well, let's start with this. A plus B plus C equals 0. So when can the sum of numbers equal 0? Well, one of them has to be negative. Like you could, for example, you could have 2, 3, then this would have to be -5. Something like that. Now let's just continue on with this case here. So just imagine we had A, B, and C be 2, 3, and -5. All right. So what would A over A be? Well, A over the absolute value of A, or let's say 2 over the absolute value of 2, plus 3 over the absolute value of 3, plus 5 over the absolute value, -5 over the absolute value of -5. Oh, come on, don't do that. Plus the product of all three, which is going to be 2 times 3 times 5 times -5, sorry. All over the absolute value of their product, times 3 times -5. Okay, what would that be? Well, this is going to be 1. That's going to be 1. That's going to be -1, right? So we're at 2 minus 1, right? 1 plus 1 minus 1. And this right here is also going to be -1. So we're going to get 0. Okay, so 0 is definitely one of the answers. All right, so now we can eliminate this. I don't like to do this way. But let's see what else. Let's come back and let's look at this in a more general sense. All right. So we determined that at least one of the numbers has to be negative, right? But what if there were two numbers that were negative, right? So say we had 3, -1, and -2. Okay, let's look and see how this works out. All right. So A over the absolute value of A would be 1. -1 over the absolute, that would be -1. And then -2 over the absolute value of -2 would also be -2. Right? Is that right? No. It would be -1, you fool. It would be -1 as well. Okay, and then this product here is going to be, let's see, if we multiply those three, we're going to get +6 over 6. So look, we're going to get 1 plus 1 minus 1 minus 1. We're going to get 0 again. So there are really only two cases. The two cases are positive, positive, negative, or they could be negative, negative, positive. It doesn't matter which A and B. So it's two positives and one negative, or two negatives and one positive. It looks like you're always going to get 0, right? You're always going to get a bunch of, two ones and two negative ones. So I'm guessing. I'm pretty sure that it is a 0. Okay, let's see. Problem 22. In the right triangle ABC, AC equals 12, BC equals 5. Angle C is the right angle. Okay, right away we know we've got a 5, 12, 13 triangle. Let me write that in. Right away. Again, we see this over and over again. A semicircle is inscribed in the triangle below. What is the radius of the semicircle? So what is a radius? So somewhere there's a center, and if we drew this line, what would be that length? All right. This question, something that I would do reflexively is always ask myself, what makes this complicated? We know a lot about triangles. We know a lot about circles. We don't know much about semicircles. So what if we didn't have a semicircle? What if we had let's say, what if we had a circle? Okay, let me see if I can pull this off. That is a circle. Let's see if it fits. Wow, look at that. That's pretty good. All right, good. So let's just look at this question. If we just, and what I did, and I want to draw on this figure, is if we just drew this line here and we just expanded our circle. Ooh, not quite that good, but something like that. Okay, forward. All right, so this is our new triangle over here. Let's just relabel it. So where am I right? Yeah, right. Okay, so this is 13. This is 13. And this is now 10, right? And let's put our line in, put this altitude in. Altitude, height, whatever you want. Oh, it's not going to let me do it. It's not going to let me do it. Let's try it from the bottom up. Let's try it with the mouse. There we go. All right. When I get close to the edges of the pad, it gets wacky. All right. The Wacom tablet. You see this? It's the pen I'm using. Here it is. All right. So what is the radius of this this circle? Okay. So let's put our right angle in there. Well, whenever they ask you for the radius, a good thing to do is just start at the center of the circle and draw these altitudes out to points in the circle. Okay. Now I'm also going to draw, let's use a different color. And let's try here. I'm going to draw this. I'm going to draw this. And I'm going to draw this. Okay, now let's look at these three triangles here. And what I mean by these three triangles, I mean this one on the bottom, this one here, and this one here. So where's my pen? Okay. So this triangle, I'm going to use purple. This triangle right here, we know that its height is r and its base is 10. So let's come over here. 1/2 base is 10 times r. This triangle here, we know its area is, I'm going to add them up, 1/2 r times 13, and the same thing on this other triangle here. So the area of the whole thing, why am I doing this? 1/2 r times 13. What do we know about the area of this whole triangle? Okay, well, we started with this one here, and this area was 1/2 5 times 12, and we already did this a couple questions ago. Half of 60 or 30. So half of it's 30, the other half, so the whole thing is going to be 60. Okay, so now we have one equation with one variable, and our variables are exactly what we're looking for, the radius of the semicircle. So now we can just double everything if you want to get rid of the halves. So we're multiplying both sides by 2, so we're getting 120, and we're getting 10r plus 26r, we're getting 36r. So now r equals, the radius equals 120 divided by 36. Ooh, it's not letting me do it. Well, I'll do it over here. 120 divided by 36. Divide the top and bottom by, we could do 12. We would get 10 thirds. That is the answer here. All right? That's why I love geometry. It's easy. But you have to understand what to do when you get stuck. You have to create right triangles. You have to turn that semicircle into a full circle. And there's actually a couple other ways to do this question. Maybe I'll mention one of them right now. Let's see. No, I'm not going to mention one right now. But there's a couple other ways to do this question as well. Okay, number 23. I don't really like this question here at all. In fact, this is almost like a Common Core type of question, and there's really no good math explanation for it. I'll read it out loud and then I'll go through it a little bit, but I'm not going to spend a lot of time on it because there really are no good math solutions to this. All right. Or it's not very educational, I'll put it that way. So each day for 4 days, Linda traveled for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. In other words, she traveled for an hour. Let's just say she ran for an hour, and one day she did 10-minute miles. Next day she did 8-minute miles. but not 8.5 minute miles or not 8.25. It was always an integer number of minutes per mile. All right, so that was her rate of speed. And I wouldn't know how to do this question if my wife wasn't always telling me all her her, her per mile minute times. All right. Each day after the first, her speed decreased, so the number of minutes to travel 1 mile increased. All right. So if you think about, if you go running, maybe your first mile is in 10 minutes, your second one is in 12, your next one is in 15, and so on and so forth. So that's what's going on with her. All right. But over a period of 4 days. All right. So each day, her number of minutes to travel a mile. What do they call that? Like your mile split time? I don't even know. Goes up by 5 minutes. So each of the 4 days, her distance was also an integer number of miles. Okay. So there's a lot of things going on in this question, and again, I don't really like it. So basically, she ran for 60 minutes at a rate of X to start out with. And then the next day, she ran for 60 minutes, and her rate went up. So her speed decreased, so her per mile minute time went up. So say she was doing 10-minute miles here. Let's just say, for example, she was doing 10-minute miles, and then here she's doing 10 plus 5, 15-minute miles, and then the next day she would do 20-minute miles. And this is why I don't like this question. So next day she would do 20-minute miles. And that would mean that on the last day she would do 25-minute miles. What's right here? 60 x plus 15. And let's go back to red. So on the last day she would do 25-minute miles. All right. The problem with this is this last thing here. Each day her distance was an integer number of miles. So in the first day she ran 5 miles. The second day she ran 4 miles. The third day she ran 3 miles. But then on the last day here, she ran a little bit more than 2 miles. So she ran 2 miles. Is it 2.4 miles? 10 over there. 2.4 miles. Now, 2.4 is not an integer. So this is the problem with this example. Now, really, the only way to do this question is to think about what 4 consecutive numbers, or 4 consecutive, 4 numbers that are each separated by 5 units, like 4 multiples of 5 in a row, divide into 60. And it turns out that you're just supposed to eyeball this and say, hey, it's 60 by 5, 10 divides into 60, 15 divides into 60, and 20 divides into 60, right? Because there are not that many numbers that divide into 60. I mean, the first number that divides into 60 is 60. Then it goes down to 30. Then 20, 15, 10, 5. Well, that's pretty much it. So you're supposed to guess that these were her speeds. That the first day she did a mile in 5 minutes. The second day she did a mile in 10 minutes. The third day was 15-minute miles, and the fourth day is 20-minute miles. Now, again, I don't like this question. I assume that anyone who's new to this country would have trouble understanding it. I'm not new to this country, and I had trouble understanding it as well. And it turns out there are no really good solutions to this other than to eyeball it and guess it. And that's what it says online, that there are no good solutions. It's not just my ignorance. All right. So if these were her rates, how many total miles did she travel? Well, 60 divided by 5 is 12. The second day she went 6 miles. The third day she went 4. And the last one, 3. So let's say 18 and 7 is going to be 25 miles. Okay, now this test, you only have 40 minutes to do this test. You can see how long these solutions are right now when you try to explain them. You can imagine, there are a lot of kids that get a perfect score on this, how fast they can comprehend and do these questions. All right, so this next question is going to be tough too. That's why you have to recognize it and know how to start it right away. Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one every 4, one every 5. Now this looks like some of the questions we did before, 3, 4, and 5. Looks like multiples of 3, 4, and 5. That looks like multiples of 60, doesn't it? And all three called her on New Year's Eve last year. How many days during next year did she not receive a phone call from any of her grandchildren? So you think about this is a pretty realistic question, right? You know, you have grandma has 3 grandkids, and they do call her regularly, and she likes to get calls from them. So approximately how often does she not get a call from them, right? So if you think about the first person, her first grandson, her real dutiful grandson, he or she is going to call them every 3 days. So over the next 365 days, they're going to call, let's see, 3 goes into 365, 12, 121. Is that right? 121. 121 times. Okay, and then the next dutiful grandchild is going to call every 4 days. And they're going to go, let's see, 4 goes into 365, 91 times. 91 times. And then the rotten grandkid divided by 5, 365. Is that right? 365 divided by 5. What is that? 5 goes into this 71 times. Okay. So if you can see that, let's see, 162 and 121. It's that 183. There's a lot of days there, 183 days that someone's going to call already. Now, there are some problems here because some days more than one grandchild calls, right? So, for example, on the 12th day, both these kids are going to call, right? Because it's multiple of 3 and a multiple of 4, right? And on the 15th day, grandchild 1 and grandchild 2 are going to call. And on the 20th day, these 2 are going to call. And then I guess on the 60th day, all 3 are going to call. So every 60 days, she gets 3 phone calls. Okay, so we can't just start with 365 days and subtract these 3 times, right? So, we can start with 365. But what we're going to do is we're going to subtract the number of multiples of 3. We're going to subtract the number of multiples of 4 that are less than 365. And we're going to subtract the number of multiples of 5, which are 71 times that the third grandchild calls. We're going to subtract those. But we also, like again, on day 12, we subtracted it twice, right? We subtracted day 12 twice. We subtracted day 24 twice because both of these grandkids called then. So we don't want to subtract them twice. We actually have to add them back in. Right, so what we'll do now is we're going to add in the multiples of 12. How many multiples of 12 are there between 1 and 365? And then that's if these two grandkids, we're going to add the multiples of 15 in. And then we're going to add in the multiples of 20. Right, because we over subtracted them. Right. So now there's one more complication here, and this is obvious to people who've seen these type of questions, is there are certain days, and I kind of hinted at it already, every 60 days, all 3 called. So the question is what do we do with those days? Okay, we counted 60 here, 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 then we subtracted it here, here, and here. So now it looks like the 60th day is not even counted in. So now we have to add in. Wait, is that right? No, we have to subtract. The multiples of 60. Okay, because they were not subtracted yet. We subtracted them and then added them back in. So really, this is what this question boils down to. And let me just show you how you get started computing it. So we would start with 365. And number of multiples of 3, we'd subtract 121. We subtract 91. I'm pretty sure these are right. Let's see, 9, 1. And that goes in 7. No, that's not 71, is it? 5 goes into 36 7 times. It's 73, I think. 73 times minus 73. I think so, yeah. Then we're going to add in multiples of 12. There are 30 multiples of 12. How many multiples of 15? 15 goes into 36 twice. I think 24 plus 24. And how many 20s go into that? 20 goes into that, I guess, 18 times? 18 times. Let me just check. Yeah, something like that. 18 times. Let me check my work. And then we're going to subtract these last 6 days. Okay, so when you do it all out, look, it gets pretty messy. Let's just 54 plus 12 is 66. Let's see. And this is, let's see, 365 minus 121 is 244. Is that right? 244, 365. Minus 91 would be minus 100. So 144 plus 9, 153. Minus 73 is 80. It's 80. So 80 plus 66, or 146. Okay. It's a very tough question. I mean, it's all right. It's not that tough of a question, but it's got some involvement. You got to do some computation there. If you can't divide 12 and 20 into these numbers real quick, you're in real trouble. All right. One more question. Okay, number 25, geometry again. I would probably skip ahead to this if I was taking the test because I like geometry. I can see everything right there. I don't have to decipher. In the figure shown, US and UT are line segments each of length 2. Okay, before I even continue on, let's get those on. Let's get those unit lengths on the figure. And TUS equals 60. All right, so now if this is 60 and these are both 2, I know this is going to be an equilateral triangle, right? Because these two leg angles have to be equal. So it's going to be a, should I even draw it? All right, I'm not going to draw it yet. So from S to T is also 2. I guess I could draw that in there. Let's hit the line. Okay. So this is also 2. And arcs TR and SR are 1/6 of a circle with radius 2. All right, we need to go back to here. 1/6. And 1/6 of a circle should tell you how many degrees is that? It should tell you right away that that's 60 degrees. Okay. So now if these are 60 degrees, if this is 1/6 of a circle, this is going to be 60 as well. This is going to be 60. Okay, so we're going to get 1/6 of a circle of radius 2. So this is 2. They're telling you these are all 2. Okay, so now they want to find what is the area of this region. So it's this red region here. Okay, so the red region is in a regular shape, and whenever you have an irregular shape, you want to represent it as a combination of some more easy or easier to handle shapes. So if we took the whole big triangle and we subtracted this arc over here and we subtracted this arc over here, horrible, we would get our red area. Okay, that would get us to this red curve in here. Okay, so let's just look at this big triangle here. It's an equilateral triangle. Now, one thing that I encourage my students to know, that the area of an equilateral triangle, is equal to side squared, square root of 3 over 4. In other words, you know the area of a square, right? An area of a square is side squared. But if we have an equilateral triangle, you want to learn this formula as well. And it just comes from basic 30, 60, 90 principles. If you took any equilateral triangle of side length S and drop the altitude, you know this is 60. No, I can't write, it's too small here. This is S over 2. This is S square root of 3 over 2. And you would just use the regular formula for the area of a triangle, and you would get this. So side squared, square root of 3 over 4. Your kids need to memorize this. You should memorize this too, even if you're an adult. I'm just kidding. But what it does is it helps you in these advanced questions and these higher level competitions to go real fast. Like right away, I know if this side length is 4, well, I know this is going to be 4 squared, square root of 3 over 4. I know this is 4 square root of 3. Okay? To takes 1 second to do when you know it, what you're doing. Now, this is 1/6 of a circle. This is 1/6 of a circle. So really 1/6 plus 1/6, we're going to subtract 1/3 of a circle, of an area of a circle. So 4 square roots of 3 minus 1/3 pi r squared. R is 2. It's just going to be 4. Okay? So it's 4 square roots of 3 minus 2 pi. And that should be 1. Wait, we do have one mistake here. Now this is not, this should be 1/3. What am I doing? 1/3. 4/3 pi. 4/3 pi. Okay, so it should be 4 square roots of 3 minus 4/3 pi, or 4 pi over 3. And we are done. I don't know how many minutes that is. I'll take a look. But as you can see, to do all these questions and get them right in 40 minutes is pretty tough. But there are a lot of kids who can do it. And even more kids who can get over 20 right. So this is a good objective measure for you and your kids. And it's astounding to me how many schools will not don't even know this exists. And I got a lot of feedback. People didn't even know there was a national math exam. And I think in a lot of these communities, a lot of these schools, especially public schools, but even private schools, they want to insulate themselves from objectivity, from comparing their results versus other people. And these things are always good good exercises to do to see where you stand. All right. I will see you maybe I'll make another video that's something like this pretty soon.